All right, so we are going to start today. And so we're going to start 3.3 right now. So assignment number 3 is about Chebyshevs rule and the empirical rule. But before we get there, let's go ahead and review a little bit about where we've already been. And so we're going to start, we started with 3.1, which was measures of center. So we had the mean, the median, and the mode are all measures of center. And we talked about summation notation, which was that Greek symbol for summation. And then in 3.2, we talked about measures of variation. So the range is a very simple measure of variation, but then we talked about the standard deviation, which we can do on our calculator. We also talked about how the standard deviation was the average distance away from the mean. And so we can calculate that with our calculator, but that we also talked about how there's a 3 standard deviation rule, which means almost always, not always, but almost always, every single observation that we have within a data set is going to be within 3 standard deviations of the average or of the mean. And so that's going to lead us to 3.3, which is what we're going to be talking about today. And this has a lot to do with standard deviation and how many data points are within a specific standard deviation. So we're going to start with Chebyshev. Chebyshev was a Russian mathematician who came up with a rule to find out how many data points are 1 standard deviation away from the mean or 2 standard deviations away from the mean. And basically what he came up with was this formula where the k value is the number of standard deviations away from the mean. So for example, if we're talking about something that's 2 standard deviations away from the mean, it would be 1 minus 1 over 2 squared. Well, that's 1 minus 1 over 4, which is 3/4. That means that 3/4 of the data are within 2 standard deviations of the mean. So that's what we're talking about right here. So if x bar is the mean, the x bar plus or minus 2 standard deviations, that means that 75% of the data is going to be between those 2 things. And if we do the same thing with 3, 1 over 3 squared is 1 over 9, and 1 minus 1 over 9 is 8/9, which is 89% of the data is going to be within 3 standard deviations of the mean. Well, what does that mean specifically? Let's take, for example, this study. Suppose there was a study of 140 adult men that found that the length of the man's forearm could be summarized in the following way. So we have the mean is 18.8 inches, but the standard deviation is 1.12 inches. So we could draw the shape of this data. Let's suppose that it's bell-shaped. It looks something like this. And it doesn't have to be bell-shaped for this. It could be any type of data for this. But we would have that the mean would be 18.8, okay, which would be this. Then we have numbers that are like 1 standard deviation away from the mean, 2 standard deviations, and 3 standard deviations. So if the standard deviation is 1.12, I could take 18.8 and add 1.12. Well, that's going to be 19.92. Then if I go 2 standard deviations above the mean, I'm going to add 1.12 again. I'm going to be at 21.04. And if I go 3 standard deviations away from the mean, that's going to be 22.16. I can also be 1 standard deviation below the mean, and 2 standard deviations below the mean, and 3 standard deviations below the mean. So what I would do is I would start with the mean, 18.8, and subtract 1.12, which is 17.68. So that would be 1 standard deviation below the mean. If I go 2 standard deviations below the mean, well, then I'm going to be at 16.56. And if I go 3 standard deviations below the mean, I'm going to be at 15.44. So, and I don't know if this is bell-shaped. It could be any shaped curve for Chebyshev's rule, but this is the interpretation that we would have. So we would want to find out first how many people are going to be within 2 standard deviations above the mean. So we're talking between 6.56, that's this distance here, and this distance here. So how many data points are going to be within 2 standard deviations of the mean? Well, that's 75% of the data. So we would take 75% or 0.75 times 140. And that's going to give us 105 of the data points. So we would expect 105 of the 140 men to have a forearm length between 16.56 and 21.04. So if we apply that same thing to 3 standard deviations above the mean, now we're talking between, let me get a different color here, now we're talking between 15.44, which is this distance, and 3 standard deviations above the mean, which is 22.16. Well, if it's 3 standard deviations above the mean, according to Chebyshevs rule, that would be 89% of the data, which is 0.89. We would want to find how many of the 140, oops, I did that backwards, 140 men would have a forearm length between those two distances. So it would take 0.89 times 140, and 0.89 times 140 is 124.6, which would round to about 125 of the guys would have a forearm length somewhere between 15.44 and 21.1 or 22.16. Okay, so we want to understand that Chebyshevs rule is a lower limit. That means there could be more than that are between those distances, and it works for any data shape. Okay, that's Chebyshevs rule. That's a really old rule. There's a more recent rule, and probably a more popular rule, called the empirical rule. The empirical rule, these are things you're going to have to memorize. The empirical rule, there's 3 percents that we're just going to have to remember. The first one is that 68% of the data is going to be within 1 standard deviation of the mean. 95% would be within 2 standard deviations of the mean, and 99.7% would be within 3 standard deviations of the mean. Here's a graph of what this, oh, and by the way, this works if the shape is roughly bell-shaped. If it's not bell-shaped, then this rule would not work. So we have the Chebyshevs rule that works for every shape of a data, and then the empirical rule works for data that is mostly bell-shaped. So it looks something like this. So here we have within 1 standard deviation of the mean, from this line to this line, that's 68% of the data is between those 2 points. Then if I go 2 standard deviations below the mean to 2 standard deviations above the mean, we're at 95% of the data would be within those 2 standard deviations. And then if I go from 3 standard deviations below the mean to 3 standard deviations above the mean, now we're talking 99.7% of the data would be within 3 standard deviations of the mean. So if we look at that, assuming that this study is bell-shaped, and same information, we still have the 18.8 inches, which is the mean, and the standard deviation is 1.12 inches, then we can conclude these 3 things. So from 17.68 to 19.92, that's within 1 standard deviation of the mean. Well, that means that 68% of these 140 people in our survey fall within that range. Well, 68% of 140 is 95 men. Then 2 standard deviations above the mean, okay, that's 95% of the data would fall between those 2 values. That's 133 out of the 140. I would take 0.95 times the 140. And then finally, we have 3 standard deviations above the mean. That's 99.7% of the data would fall within 3 standard deviations of the mean. And so if I take 99.7 times 140, that would actually round to 140. We would expect all of the men to be within 3 standard deviations above the mean. Okay? That's the empirical rule. So how does that apply to something else? Let's just take a look at this situation. Polychlorinated I don't even know how to say that, biphenyls is an industrial pollutant banned in the U.S. in 1979. The following study came out in 1972 in parts per million of 60 pelican eggs. So these are parts per million of this pollutant that is supposed to be bad, evidently, for pelicans. And so if we find this data, we would first plot it on a frequency or a histogram so that we can kind of grab the shape of this. And you can kind of see this is kind of bell-shaped curve, which means we're going to use the empirical rule for this. And so if we were to use the empirical rule for this, we would use the 68%, the 95%, and the 99.7%. But in order to do that, we'd first have to find the mean and the standard deviation. So if we do that on our calculator, we would get that the mean is 206.45 and the standard deviation is 66.42. So if I add 66.42, I get one standard deviation above the mean. If I add 66.42 again, this is two standard deviations above the mean, and finally 3 standard deviations above the mean. And then I could go the other way too. If I subtract 66.42, this is 1 standard deviation below the mean, 2 standard deviations below the mean, and 3 standard deviations below the mean. And then we can come up with these conclusions. We would say that 68% of all of the data values would be within 140.03 and 272.87. That would be 68% of the data. Then I could go on and I could say that between 73.61 and 339.26, that would be 95% of the data. And then finally, if I go on to the last one, between 7.19 and 405.71, that 99.7% of the data would fall between those two values. All of this is using the empirical rule. And again, the reason we use the empirical rule here is because the data was bell-shaped, okay, or at least close to being bell-shaped. All right, that is 3.3. There is a homework assignment in Math Excel that we'll go over tomorrow in class, and we will see you then.